All right, hello and welcome back. This is another ALEKS video that's called Predicting Qualitatively How Entropy Changes with Temperature and Volume. So this is a pretty neat little topic. Basically, we're going to have to sort of look at a different system. It's going to undergo a change, and then we're going to have to determine how we would predict the entropy of the system to change. So really, we've got to have a good understanding of what entropy means, sort of what that entails essentially, and then go ahead and sort of analyze these different manipulations or changes that the system will go through to determine what's going to happen. And basically, the entropy is either going to decrease. So this one here, this selection here, this indicates that the entropy would be decreasing in the system. Basically, the ways in which we can arrange everything would be less. This would mean the entropy is staying the same. Very rare in this topic I found. This would mean the entropy is increasing, so there's going to be more ways in which to arrange the system. And then sometimes there's going to be not enough information. And the way that this not enough information is going to arise, basically, is if the temperature is going to be doing one thing and causing one change in the entropy, and then the volume change is going to be doing the opposite. So we will probably interact with some of those examples while we're going through this learning progression, but that's sort of what we're going to be looking for. All right. In any case, let's go ahead and jump into it. A few grams of liquid water. So this is the system. The key thing to be looking for here, the amount is really not important. You'll notice that it's changing here between the different systems, but what's really important is the phase of what we're looking at in the system. So in this case, we're looking at a liquid. So, I would just imagine some water in a glass. And then the change, the water is heated from -3 to 0 degrees Celsius. So we're warming the water up. The fact that this is negative is actually sort of interesting. We might get confused here, but the fact that the system is liquid and then the water is heated from -3 to 0, all we need to pay attention to is that the water is being heated up. If we're heating a system up, that's going to be an increase in entropy. As you heat something up, the molecules are going to be moving around more rapidly. That means there's going to be more entropy. There's more ways we can arrange that energy, essentially. All right, let's do the next one. A few moles of nitrogen gas. So nitrogen, what we're looking for here is that it's a gas. The gas is cooled from -2 to -13. So we're going from -2 to -13. We're cooling it down, so that means the entropy would be decreasing for this portion of this change. Is also compressed from a volume of 15 liters to a volume of 10 liters. So again, this first change is decreasing the entropy, and then the second change is also decreasing the entropy. We're compressing from a volume of 15 liters to a volume of 10 liters. So both of these changes would be decreasing the entropy. Therefore, obviously, it's going to be decreasing, right? This would be a situation where if they're opposite, then there's probably not going to be enough information for us to know. All right, let's do the last one here. A few moles of nitrogen gas. The nitrogen gas expands from a volume of 10 liters to a volume of 11 liters. So that would be an increase of entropy while the temperature is held constant. So if the temperature is held constant, that's not going to make any change in the entropy. So this one, all we're worried about is that the volume is increasing from 10 liters to 11 liters, increase in entropy. So that would be this one here, right? All right, so I feel like I talked a lot in that one, so we'll probably just do one more here. We won't finish the full learning progression. I don't think that's necessary. So a few moles of helium gas. The helium is heated from -18 to 40, so increasing in entropy, heating something up, increasing the entropy, while the volume is held constant. So volume held constant is not going to make any change. Increase in entropy here. A few moles of nitrogen gas. The gas is heated from -16 to 62, so we're obviously increasing. And then the also expands from a volume, so also increasing as well. So both of these are increasing, so we're going to choose this one. A few grams of liquid acetone. The acetone is cooled from 82 to -11. So pretty simple here. If we're cooling something down, the entropy will be decreasing, and that'll be that. There is one more, so maybe I'm going to continue this video just to see if we get an example. Yeah, this is a good one. Okay, so I'm just going to do this first one here and talk about this. I'll probably do the whole thing. A few grams of liquid water. the water evaporates. So in these cases where they just tell us about a phase change, this is like another aspect of this topic that's actually pretty cool, I think. So when we have a phase change, even though the temperature is held constant, the phase change will increase the entropy. Well, in this case, because it's evaporating, but the phase change will change the entropy, I guess I should say. So in this case, if we go from liquid water to gaseous water, so we need to know what these words, these phase change words mean. If we're going from liquid water to gaseous water, the entropy will be increasing, right? So if we think about a solid to a liquid to a gas, the solid is going to have the lowest entropy, the gas is going to have the highest entropy. And so for these phase change ones, we need to pay attention to that essentially. So in this case, that would be an increase. Let's just go ahead and finish this because you know I was going to do that. A few moles of helium gas. Helium is compressed from a volume of 9 to a volume of 5, so decrease in entropy, temperature held constant, decrease. Nitrogen gas, the nitrogen's heated, increase, also compressed. Not enough information. So I think this one, I don't know if we even got one of these in this video, but obviously in this case, we're going from, this change would increase the entropy, this change would decrease the entropy. So if they're conflicting, that's going to be not enough information. All right. Cheers.